Imagine floating in the vast emptiness of space, hundreds of miles above Earth. The planet below is a mesmerizing blue and white marble. Inside your spacecraft, you and your crew are preparing for a critical mission. Suddenly, an alarm blares. A system vital for your return journey has failed. This isn't a scene from a Hollywood movie. This was the reality for the crew of Space Shuttle Columbia on mission STS-61C in January 1986. What happened next was a masterclass in crisis management, a story of human ingenuity against the unforgiving backdrop of space. This is the incredible and often overlooked story of the mission that nearly went wrong, just days before the tragic Challenger disaster would change spaceflight forever. On January 12, 1986, Space Shuttle Columbia thundered into the Florida sky. On board was a diverse crew of 7, including the first Costa Rican-born astronaut, Franklin Chang Diaz, and a then-sitting Congressman, Bill Nelson, today is the administrator of NASA. Their primary mission was to deploy the SATCOM K-1 communications satellite, a routine but crucial task. They also had a packed schedule of scientific experiments, including a Comet Halley active monitoring program, or CHAMP, designed to photograph the famous comet as it made its once-in-a-lifetime journey through the inner solar system. The crew was excited. The launch itself had been a nail-biter, scrubbed and delayed a record 7 times due to weather and technical glitches. But now, they were finally in orbit, and everything seemed to be going according to plan. The first few days of the mission were textbook perfect. Crew worked in shifts, meticulously following their flight plan. They successfully deployed the SATCOM satellite on day 2, watching it drift away from the payload bay to begin its journey to geostationary orbit. It was a flawless execution, a testament to the years of training and preparation. With their main objective complete, they turned their attention to the long list of secondary experiments. The mood in the cabin was professional but upbeat. There were astronauts, living the dream, conducting science at the frontier of human exploration. They photographed Comet Halley, ran fluid dynamics experiments, and grew protein crystals in microgravity. Everything was nominal. But in the world of spaceflight, nominal can change in a heartbeat. The crisis began subtly, without any dramatic explosions or Hollywood-style chaos. It started with a single, ominous reading on a control panel. One of the 4 main electrical buses, think of them as the primary circuits powering the entire orbiter, was showing a problem. A sensor indicated an issue with an electrical component called a transducer, which was crucial for monitoring the health of the electrical system. Initially, mission control in Houston and the crew on board weren't overly alarmed. Space shuttles were designed with incredible redundancy. With 3 other healthy electrical buses, the loss of one sensor on one bus wasn't a mission-critical failure. They noted the issue, logged it, and continued with their work. However, the problem wasn't with the sensor. It was much deeper and far more dangerous. The real culprit was a short circuit. Deep within Columbia's complex wiring, 2 wires had rubbed against each other, wearing away their protective insulation until the bare conductors touched. This created an unintended path for electricity, causing a surge of current. The transducer sensor that initially flagged the problem was just the first victim. It was essentially fried by the electrical short. The bigger danger was that this short circuit was in a system that was absolutely essential for landing. The shuttle's landing gear, its brakes, and its nose wheel steering were all controlled by pyrotechnics, small explosive charges that fired to deploy the gear and activate systems. These pyros were powered by the very electrical bus that was now compromised. If the short circuit worsened, it could prevent the landing gear from deploying. A belly landing in a space shuttle was not a survivable scenario. Houston's engineers worked around the clock, analyzing the telemetry data. They quickly realized the sensor wasn't the problem, but a symptom of the underlying short circuit. The situation was now far more serious. The short was intermittent, meaning it wasn't constant. It would appear, then disappear, making it incredibly difficult to pinpoint. The engineers on the ground simulated the failure, running through every possible scenario. Their conclusion was chilling. There was a genuine risk that the commands to deploy the landing gear could be disrupted by the short. The mission had to be cut short. The crew of Columbia, floating peacefully in orbit and unaware of the full gravity of the situation, was about to have their world turned upside down. The call came from Houston. Columbia, Houston. We've been looking at the data from your electrical bus, and we have a problem. Mission Control calmly and professionally explained the situation to the commander, Robert Hoot Gibson. The CHAMP experiment to photograph Comet Halley had to be abandoned. All non-essential systems were to be powered down to conserve energy and reduce the strain on the electrical system. The primary goal was no longer science. It was getting the crew and the orbiter home safely. The mission originally planned for 6 days would be cut short by at least a full day. The crew immediately shifted from being scientists and operators to being test pilots in a potentially compromised vehicle. Their training kicked in. There was no panic, only focused determination. They methodically worked through the new checklists, preparing Columbia for an early and uncertain return to Earth. The revised plan was anything but simple. To minimize the risk, the crew and Mission Control devised a clever but tense workaround. They would attempt to land using a different combination of electrical buses and systems than they had ever used for a real landing. This involved rewriting procedures in real time. The astronauts in orbit and the controllers on the ground essentially had to re-engineer the landing sequence from scratch. The tension was immense. Every command sent to the orbiter, every switch flipped in the cockpit carried enormous weight. They had to be sure their new plan would work. There would be no second chances. While the shuttle could glide to a landing, it couldn't go around for another try if the gear didn't come down. On January 18, 1986, 4 days and 21 hours after launch, Columbia began its descent. Inside the cockpit, the atmosphere was electric with focus. As the shuttle streaked through the upper atmosphere, glowing from the heat of re-entry, the critical moment approached. Commander Gibson reached for the landing gear switch. In a normal landing, this one action would send the electrical command to fire the pyros and deploy the gear. But this was not a normal landing. Following their newly written procedures, they had rerouted power and isolated the faulty circuits. Gibson activated the command. For a few heart-stopping seconds, the crew and everyone in Mission Control held their breath. Then 3 green lights illuminated on the console. Gear down and locked. A wave of relief washed over the cockpit and the control room in Houston. The plan had worked. Minutes later, Columbia's wheels touched down on the runway at Edwards Air Force Base in California. The shuttle rolled to a perfect stop. The crew of STS-61C was home safe. They had faced a potentially catastrophic failure and, through their skill, professionalism, and the tireless work of the team on the ground, had brought their ship back in one piece. Their mission is often overlooked, overshadowed by what came next. Just 10 days after Columbia's safe return, the Space Shuttle Challenger lifted off on its fateful mission, STS-51L, and broke apart 73 seconds after launch. The Challenger tragedy would ground the shuttle fleet for nearly 3 years and forever change the space program. The story of STS-61C is a powerful reminder of the razor's edge on which astronauts operate. It highlights the incredible complexity of the space shuttle and the inherent dangers of spaceflight. But more than that, it's a testament to the human element of exploration. It shows how quick thinking, calm problem-solving, and teamwork can overcome even the most daunting technical failures. The crew of Columbia didn't just complete a mission, they survived a crisis, demonstrating the resilience and ingenuity that defines the spirit of space exploration. It's a piece of history that deserves to be remembered, a story of success born from the brink of disaster. Thanks for watching. If you found this story as fascinating as I did, be sure to like, subscribe, and hit that notification bell for more tales from the history of spaceflight.